So in this video we're going to discuss AC generators. Before getting into it, if you remember, from a DC motor there is an energy conversion. You get kinetic to electric, electric to kinetic, you get mechanical. Kinetic is the same as mechanical because kinetic energy is mechanical energy, so you can get away with using either one. But in a DC motor, if you remember, we converted electrical energy into kinetic. You used a battery and it made something spin. That's how motors work. Now, AC generator will be the exact opposite. We will end up taking our kinetic energy by moving something, by moving a shaft, we will use it, and that, as it spins or moves, that will create electricity using induction that we learned from Faraday's law. We knew that moving a magnet in and out of a coil, that can create a voltage, but it's quite difficult to sit there and make a magnet move in and out. You'll be sitting there moving your hand, you'll get tired. So we can use another way of moving it. You can move the magnet, or you can, in this case, move the coil. Remember I mentioned that either way will work. So this is AC generators. This is what I mean. This is a little diagram. We have the magnetic field from these two magnets going from north to south. Here is my little coil here. We call this the armature, by the way. The coil is usually wrapped around this armature like that. It's wrapped all the way around. And we will spin it. We will rotate it in any way that we would like. You can be creative with the ways. We can use water, we can use our hands, we can use a bicycle, whatever. You can spin it any way you like. As it spins, you will create electricity. We need to know the parts of this. We need to know the slip rings, the carbon brushes, the armature, the coil, the magnet. These are the parts we need to know. Okay, I have written it a little bit here for you. So we have the north to south. This is the axle that it's on. This is the armature with the coil wrapped around it, and you have the two slip rings. So what is this for? The armature is the thing that moves. The coil is the part which actually has the current flowing through it. The magnet is needed so that we can have some sort of field. Of course, we use this axle to make it move. The slip ring is connected to the armature and a brush, which is connected to the load. The slip ring itself will move along with this armature, continually moving, and it is connected to this little brush here. This brush maintains contact with the ring as it is moving, so that the electricity that is generated through here can pass through the slip ring, through the brush, and into whatever I have, a bulb or whatnot. This is how it works. There's a little Quizlet on this topic, and a little remedial clip that will explain the diagram for you as well. Now let's understand the workings of it. This is induction. As we're rotating, we will convert our our mechanical energy, which is the same as kinetic, I suppose, into electrical energy. As it turns by any external means, like I said, as you rotate it any way you like, you will induce this EMF and a current will flow. Every half turn, which is 180 degrees, so as you're spinning, you'll change the direction, of course. The direction of the current will also reverse because of this. The current will be maximum when the loop is parallel to the field, and it will be zero when the loop is perpendicular to the field. Now let's see what it means. Like, what does that look like? This is what it looks like here. This is parallel, so you see the field going to the right. This is the face of my loop, and this is parallel. This is perpendicular. This is not good. When it's perpendicular, you will get zero current flowing. So at this, you will have zero EMF, zero current. As this starts to rotate and it starts to spin to this position, we are now increasing my voltage. And at this exact point, we are flat. We are having the face parallel. If you use the right-hand rule on the right side and the left-hand rule, or should I say the right-hand rule on the left side as well, you will have some sort of motion. You have this force. Don't need to know it, don't need to do it, so I won't explain it. We did do this in term 1. We don't need to continue on that part yet. So it spins. As it's spinning, of course, it goes back to this position, which is going to be 0. So it will reduce, and comes to here. Now, if you apply the right-hand rule here, it will not work. They will just cancel each other out. You will get nothing. You will get no force, which is why. Again, don't need to know that part. We just need to know the direction, the orientation, and the voltage according to that. So now, perpendicular, 0. But now this face has moved to the other side. Look at that. The shaded line has moved to the other side. Now it was on the right hand side before. Now it's on the left hand side. It is facing the opposite direction. It is now facing downwards, which means it will be in the opposite direction. The voltage will be going to the negative side. And then I will keep rotating. As it rotates back to the perpendicular position, you go straight back to 0 again. And this creates a nice little sine wave. This is how you can find the EMF using the graph.